And guys, today is going to be Carbachol mnemonic, and I'm also be explaining what is Carbachol. And here's the mnemonic. So it can cause contraction of the pupil, and that is meiosis. I'll explain this later. So yeah, it can cause, it's A as agonist of cholinergic. R is it can cause release of epinephrine. B is that it allows the Carbachol can bind to both nicotinic and muscarinic receptors. A is that carb A can be adverse effects are very low. C is that the cardiovascular and GI effects are they can cause stimulation and depression. Carb and A can be obviously due to the fact that there can be atropine opposed. Sorry. There's no A again. Where there's H over here, which is this high potency. Over that's opposed to atropine. L that is long duration, so it can last for 24 hours. So first of all, guys, I want to be to guys, in order to understand this mnemonic, I'm just going to be quickly explaining to you guys carbachol basic information. Carbachol basic information is that it is a agonist. It is a cholinergic agonist. So what does cholinergic mean? Cholinergic can mean that it is something that is it has the effects of acetylcholine, and it stimulates a receptor. So that's the meaning. That's why I've written acetylcholine in the brackets, because cholinergic is basically acetylcholine and it's an agonist. It can go and it can agonist means that it stimulates a receptor and which causes biological effects. So mimic the effect of acetylcholine by binding directly to the cholinergic receptors, such as muscarinic and nicotinic. And there are two types of cholinergic drugs. So two types of cholinergic drugs, not carbachol, of cholinergic you can say drugs or agonists, and those are cholinergic esters or alkaloids. So esters are basically esters, if you know from biochemistry, that the C double bond O and then CO, which I've shown here, and these are like more like, I guess, natural. I don't know how to not sure what the classification is over here. But alkaloid is something that's synthetic, sometimes like artificial. So for example, if we look at the cigarettes are the cigarettes, they can obviously have this sort of nicotine in them, which I believe is synthetic. Carbachol, what is the functioning? What does carbachol bind to? It binds to both nicotinic and muscarinic receptors. So what does any of that mean? If I were to draw like the if I were to draw over here, sorry about this. Yes, if I were to draw over here the if I were to draw a preganglion over here, and I would say, okay, this is the a nicotinic receptor of the sympathetic. Let's say I'm right now drawing a sympathetic system, okay, and then I draw another sympathetic system, which is the this is also the same part of the sympathetic nerve, not sympathetic, the PNS, the parasympathetic nervous system. And I were to say that, okay, this circle over here, this indicates acetylcholine. It can bind to the nicotinic receptor, and then also this same acetylcholine can go here and bind to this nicotinic receptor, and this nicotinic receptor of the parasympathetic system is, for example, present in our adrenal gland. No, not adrenal gland. That would make sense. I would say CNS. Okay, this is present in our CNS. So the cholinergic drug can go. The cholinergic drug, the carbachol drug can go and it can bind to nicotinic receptors. And if I were to similarly show you guys, sorry guys, this one would be the muscarinic, but the point is the same, that it can bind to muscarinic receptors. And if I were to, like, for example, draw the same exact thing, that okay, we have over here a acetylcholine, and this goes and it binds. Right now I'm just drawing the neuromuscular junction, which everyone knows about, and this binds to a nicotinic receptor on the neuromuscular junction, and that's by acetylcholine. And similarly, carbachol can go and bind over here. Carbachol can go bind over here, and it can also be an agonist, so it can somehow stimulate it. So what my point is, carbachol can bind to nicotinic receptors, and carbachol can bind to muscarinic receptors. That's my point, which I'm trying to make and show it to you guys. So like I've kind of shown that here, and I'm just going to be deleting that just to move on. What is the structure of carbachol? Carbachol structure is important because that's how we can put it into the classification, as I spoke about the two categories over here, a choline ester and a alkaloid. But we can put this into a choline ester due to the fact that there is a choline ester plus a carbamic acid. So your first question must be, what is a carbamic acid? I'm going to be explaining that to you guys. Just give me a minute. And it, like I said, it's a post-rupture to acetylcholine esterase, and esterase can be biotransformed at a very slow rate. What is esterase? I believe I got this information, this full definition from the Wikipedia. And by the way, I forgot to mention that all of my information, even this mnemonic, all the slides that you'll be seeing, all my information, or majority of it, is either from it's from Lippercourt's pharmacology, and a very small point of it is from the Wikipedia. Okay, so now, yeah, so carbamic acid is NH2CO. So we can see NH2 over here and a CO over here. And this is also an ester, so COO. But this is beta-alcohol. So beta-alcohol is very similar to carbachol. And yeah. Okay, now what is the action of carbachol? It mimics the paraneoplastic syndrome, right? But no, sorry, the parasympathetic system, right? How? It basically is acetylcholine. So it can go and bind to the CVS and the GI system. It can cause them to get stimulated and then depressed. Why am I saying stimulated? Because as you know, the parasympathetic system can go and it can bind to your heart, bind to your GIT, cause more contractions of the GIT, so it can stimulate it, but it also depresses it. So that's a bit of a problem there. And it can also, like I was explaining in the previous slide, it can bind to the adrenal medulla. So if you imagine you had an adrenal medulla over here, and if you just, I'm not going to draw the nicotinic, and maybe you can just imagine that there is a small nicotinic receptor present on the adrenal medulla, and then basically what can the carbachol can go and it can basically bind to imagine this is the full carbachol. It can bind to it, and then once it binds to this to the nicotinic receptor present on the adrenal medulla, you can cause the release of epinephrine. Imagine this is the epinephrine releasing from the adrenal medulla. Mimics acetylcholine, that it causes meiosis, and it basically can go to the ciliary body and causes there to be constriction of the eye. And I'm going to be diving into this in the next slide as well. So okay, and the posing of this is atropine. So the atropine, because it's a muscarinic blocker of the eye. So if I were back in the old slide, like I was saying, on the muscarinic is present on the GIT, the CNS. So if something is there, such as atropine, which is blocking it, that's a big problem, because then your carbachol cannot go there and act, or your acetylcholine cannot go there and act. So the moral of the story is that atropine is the opposer. Guys, what are the therapeutic uses of carbachol? Where can it be used? Like I said, the CVS, the GIT are really good use, but the main thing I want to talk about is high potency. Why the underlying high potency? High potency is there because if you give a small amount of carbachol, it can cause a big effect. It's very potent, it's very powerful. You give low concentration, it can cause big effect. High potency. The next thing, like I said, is non-selective. Non-selective, like I explained to you guys over here, that can bind to both. It can bind to both nicotinic and muscarinic. It's not really very selective that it only binds to nicotinic, only binds to muscarinic. And like I said, this non-selective, I've got this from my university lectures, and this high potency, the source is Wikipedia. And another thing, I believe I got this from my university, or I'm not sure where I got this from, but university lectures, by the way. And it is that it is not very it's very less used. Why is that? Because it's only therapeutic uses for the eye, and I'm going to be explaining all of that. So basically, it causes decrease of intraocular pressure, and this is when there's some sort of problem, which is like glaucoma. I'm going to be explaining all of that. Don't worry. It causes increased pressure. Okay, anyway, let me explain this. Imagine this is the eye. Okay, this is your eye. This is your main lens inside. Okay, this is your ciliary body, which I've drawn over here, and this is your zonular fibers, which are attached to the ciliary body, and this is your iris, and this is your drainage system, so your trabecular meshwork or your canalus canals. And the same thing applies on the other side. So you're also going to be having a ciliary body on the opposite side. You're also going to be having zonular fibers on the opposite side of the eye. So this is all in the same eye. This is basic anatomy, nothing really special over here. And you're also going to have iris over here. I just haven't drawn it because it would just take me too much time, but I think you guys are trying to, and obviously this is the eye, this is the optic nerve here, retina, whatever, and this is also the drainage system here. But the point I'm trying to make is that basically doing glaucoma is that the ciliary body, it makes aqueous humor solution, which I hopefully have identified it properly. It makes aqueous solution. It kind of goes in here, and then it goes in this drainage network. This drain network is over here. It's known as the trabecular meshwork, or the Schlemm, which I've drawn over here, and it gets drained over here. But when there's too much doing this, when there's too much of this occurring, what happens is that it causes glaucoma. But what carbachol causes, the carbachol drug, it comes along. Let's just imagine this is our carbachol, a big carbachol here. This is our drug, carbachol. And carbachol, what it does, it actually just goes and it hits this. It hits your ciliary body. It binds to it. It causes there to be increased amount of outflow. So more amount of the fluid goes into this drainage system. So when you have less fluid over here, you're going to have less disturbances to something like the optic nerve, and that's what it's going to be really doing. So why are we using in surgery? Because this carbachol can cause increased outflow, and this can cause a decreased amount of pressure. So that's the main problem. And adverse effects, are not many adverse effects. Why is it not enough adverse effects? Because it's a quaternary structure. That means it has 4 nitrogen atoms, ions, nitrogen ions, I would say. So, and that does not allow it to cross the blood-brain barrier. So you just imagine carbachol cannot go to your brain, and when it's not go to your brain, there's not many. It doesn't really have many systemic adverse affections. It doesn't have many systemic penetration. So this can make so much more sense for you when you look at this mnemonic now. Carbachol, what is the main organ that it hits? Your eyes. It hits the ciliary body, causes there to be contraction, causes the lens to become bigger, causes more accommodation, but essentially causes there to be meiosis. Hits the ciliary body, causes there to be meiosis. Sorry. Yes, it causes there to be meiosis, constriction. What is it? It's a cholinergic agonist. What is R? It releases epinephrine from the adrenal medulla. What is the A? It is that it causes adverse effects. Adverse effects are low. I forgot to say B. B, it is that it's non-selective. It can hit both your muscarinic or your nicotinic. So it can maybe hit your neuromuscular junction nicotinic, or it can hit the nicotinic on your adrenal medulla, or it can hit your muscarinic, which is obviously present in your GIT. So it can hit many places, but obviously doesn't. It can cause cardiovascular and GI effects, like I said so, and it is ganglionically stimulating. So first it stimulates and then depresses. So first it could possibly cause your GI to work fast, and then it causes decrease. What's H starting in carbachol standing for? It is high potency. So if you get low amounts of drugs, you're saying a high potency. What is O? O is opposer. O, opposer of atropine. Atropine essentially goes and it blocks muscarinic. It's a muscarinic blocker. So, for example, let's just look at your stomach, your GIT. It has muscarinic receptors on it. Atropine can go block it. So your carbachol cannot hit that muscarinic receptor there. Whereas L, that it has very long effects. It has a long effect of 24 hours. So this is the mnemonic. Hopefully you guys found it useful. Please do, thank you guys for watching, and hope to see you guys next time if you like this content.